All right, everyone, we are back and we are about to do our pre-lab for our basically our chi-squared analysis and determining whether things are normally distributed or whether things are as they appear to be. So we're going to be working in our lab with a Bob Ross data set, but I want to work and do a little pre-lab and let's actually demonstrate some of the topics that we're going to hit on in the actual lab, but now with Ramyun, specifically Ramyun from South Korea. So I'm going to bring in my libraries, tidyverse, our usual suspects, library. And again, if these don't show up for you, remember, you can just install the packages. Let's do library r statics for filter function library. You should have stats, but just to make sure. And we're going to read in a new package today. So install.packages, and we're going to do environmental stats. And this is going to allow us to do a goodness of fit test and to test whether distributions are normally distributed in R. So it's a cool feature. So I've already installed it, but I just want to show you all. So let's read all these in, install the packages. Good. So let's go ahead, and I'm actually going to go into our data sets. Let's go to, where are you teaching? I'm going to go to 322. I'm going to go to labs. Actually, I should go into, but goodness of fit chi-squared. Here we go. So I'm going to do, first I'm going to set my directory. And then I'm going to do Ramyun, read.csv, and then let's do Ramyun rating.csv. What don't you like? Maybe it needs a double. Make sure my working. Should be fine, my working. Ooh. Maybe I need, let's do library. No, I think read CSV should be fine. Ratings. Always a spelling error. All right, good to go. So let's take a look at this data set. So if I look at Ramyun, there's lots of different Ramyun, and I want to look at the following. So I want to see all of the Ramyun from South Korea. Is the rating normally distributed or not? So I want to test, does this sample of ratings come from, or ratings of Ramyun come from a normal, are they normally distributed? So I'm going to do ratings, set as a variable, and I'm going to take Ramyun, and then I'm going to pipe it. I'm going to filter based on country, and I only want South Korea, and I'm going to pipe it, and then I'm going to select, because I only want to select basically the stars, so like the rating, and then I'm going to drop .na, everything. So there we go. And we can take a look at, let's see, ratings. And we see we got all of our stars, lots of ratings. Excellent. So let's take a peek at this data set first off. So let's go ahead and we're going to take ratings, and then we're going to pipe it to ggplot. I'm going to set my AES. X is going to be my, basically, my stars. And that's going to be it. And I'm just going to do plus geom histogram. And then let's see what we got here. That's a little bit ugly, but I can change bins equal to 10. And again, I expect you all to do a very nice one. So already you can see this doesn't really look too normally distributed. But let's prove this quantitatively. So this is where this package here, env-stats, comes into play. So what we're going to do is we're going to do something called G of test, and we are going to read in our data set. So our data set is going to be ratings, bracket 1. Oops, not too many brackets. Bracket 1. So we're going to read in all of those. So we're going to take this ratings. We are going to read it into our function G of test, and we could actually get some help. G of test. look at some of this. So it shows you effectively here all the things that can kind of go into this function. So you can read through, but we are going to test whether we are normally distributed or not. So we're going to read in our data set, and we're going to set some of these testing expectations. And this is going to be our test that we're going to run is, we're going to run a chi-square test. So this is going to allow us to look at distributions which we weren't really able to do unless we were dealing with our other data set. So I can look at distribution. There's multiple ways you can do this, but I would suggest this. Chi-square test, we're going to test whether the distribution is normal. We're going to also read in this n.classes, and this is basically looking at your degrees of freedom and looking at the number of bins. So this is based off the paper, length of ratings, bracket 1, and we're going to do this length, and actually you can see it here. So if you go to n.classes, n.classes, you can see the default value is this. So actually we don't even have to specify that number of classes. But we do want to set our param list, and we're going to have a list where we're going to test again. We're going to say that the mean should be equal to, mean equals mean of ratings. So again, for our normal distribution, and then the standard deviation should be equal to SD of ratings, bracket 1. I think it doesn't like, what don't you like here? Oops. Param.list. Actually, I think I see the difference here. All right, I think I missed one. There we go. So we did our test method, chi-squared. This was our hypothesized distribution based on our data set. You have our sample size, degrees of freedom based on our n.classes. And you see we have a very, very, very large chi-square test value. And we see our p-value is equal to 0. So our alternative is true CDF does not equal the normal distribution. So this is our H0. So again, we are, or HA, or our alternative hypothesis. So we can now take this, and we see the p-value is 0. So that is basically a huge reject. So those frequencies are not the same, which makes sense if we look back at our plot here. So that was a nice way that we are able to look at and analyze that data set. So pretty cool. Now, I want to give you a little bit of a tip. I think that's going to help you significantly through a lot of this data set, but I want to kind of introduce some other functions that may be helpful as you run through your data set as well. So let's look at, for example, I want to read in, and actually we're going to do this right now on the fly. I'm going to read in a data set, and let's go ahead and read in, I always like the Scooby-Doo data set. It's always fun to me. It makes me feel very nice. So let's go ahead and let's look at, for example, let's read in this data set. So I'm going to go ahead and I'm going to copy my Scooby-Doo into my goodness of fit, and we're going to read that in. So I'm going to do, oops, let's go over here, Scooby-Doo, read.csv. I love that Scooby-Doo. It's too fun. How can you not ask questions about Scooby-Doo? So Scooby-Doo data set, we can look at that as well. So I want to, let's say I want to count, the number of times Fred, caught Fred. or maybe captured. Yeah, let's say caught Fred. Let's say the ones that Fred caught. So caught Fred. So let's say we wanted to look at Scooby-Doo. Let's go back one more time. And let's say we wanted to look at the number of times there was arrest made in Scooby-Doo. So we can go ahead and do Scooby-Doo. And we can do pipe it. And we can df select. And then arrested. And then we can take that data set. And then we can look now for, let's filter our data set, which is arrested, set equal to true. And we can look at the dimensions to figure out how many times we counted that. So dimensions, true. Dimension, or just dimensions of that. So 381 times you can see it true. There's another function you could use and highly recommended for your Bob Ross data set. It's call sums. And if you do na.rm equals true, it'll count in a similar fashion how many times you see true appear. It has to be a numeric data set, so it's not going to work for the Scooby-Doo data set, not the stupid Scooby-Doo set. So you can look at this and say, okay, well, is it, if we looked, for example, at just the dimensions, so we found it was 381. If you just look at the dimensions of the non-filtered data set, here, 603, you can do a chi-square test looking to see if they're evenly distributed. And if you have to repeat a value multiple times, so I could repeat, let's say, a value of 5 15 times, or times equals 15, and that'll give me my data set of like unexpected probability. Hint, 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 use this on your Bob Ross data set. So that's a cool way to go about it too. Additionally, if you're ever having to basically pull out like the top values, like for example, the top column here of a formatted data set, you can go ahead and use this, use a value called unname. So for example, I can look at, so I can take a data set like Scooby-Doo. Let's go from 10 to 27. And you can see I got a bunch of these values here. If I want just the top row, I can do unname. I can unname this. And I can look at just some of the values that are in there. So it may be a helpful data set just in case, again, in case you need to use unname, for example. So you can look at Scooby-Doo, it's going to give you essentially that TV series and some other values that may be helpful for you. So unname, that function. So you may want to look at unname. You may want to look at, again, that column sums. So again, call sums, perhaps, and use those functions in your data set. So best of luck, and we'll see you all next time. And if you ever want to do a bar plot, geom and geom bar. So just a couple hints for your Bob Ross data set. So best of luck, and we'll see you all then. Thanks.